He has been seen in a unicorn onesie before. And he's local. And he has been so kind as to help with some of the logistics of the conference as well, shipping people about. He's a good guy.
Thanks.
And if you were following Eunice's talk earlier, she spoke about the performance to some degree of the blend modes and filters and things like that. And Martin is going to get really into the nitty-gritty of these things and what goes into painting pixels on the screen and what we can do to help the browser do it. So he is going into and beyond CSS, looking at the 2D canvas and WebGL as well.
Correct. That's
so please warm up your hands and give a round of applause to introduce Martin.
Cheerleader, that's a new one. Thanks a lot, Laura, for warming up the audience and me as well. And thanks everyone for showing up after such great talks. I feel a bit like a fraud, really, but let's see if I can make up for that bad feeling. So yeah, today we're going to talk a lot about pixels and a lot about rendering and all that kind of stuff. So why am I here to talk about that kind of stuff? Because I was like, a couple of years ago, I was like, rendering, I want to have the browser deal with that, and I just do the cool stuff. Now I realized rendering is the cool stuff, so I kind of moved into that a little bit, and I work at Archeologic where we use WebGL a lot, so we have to squeeze performance a bit here and there. And it actually gets you into the dark corners of web performance, which is fun. So let's start with the basics of what goes into rendering a web page, right? So first things first, performance, so performantly rendering something, is actually the art of avoiding work, which is what I should probably print on my business cards at some point because I'm really good at that stuff now. Paul Lewis said that. It's not me. It's not just me trying to basically sneak out and get a buck from doing nothing. We're multiple people. So rendering is basically, it is very basic about putting points onto screens, right? So we're going to paint a lot of stuff. And the thing is, as you can see with this GIF, it is a nice GIF. However, it takes a little while until the entire, face is there. So painting might not be something that we want to do too much, right? Because it takes a little time. So for rendering, it's not just about painting pixels. There's more involved than that, because you know that we are actually not really uploading images. I know there's a bunch of people who think web design is all about Photoshop files, but it's not. So we have to basically do a little more work than just printing out pixels or spitting out images, really. So what we have to do is we have to construct our content in HTML. We're then going to style it and move it around and change the appearance of it with CSS. And then we change the behavior using JavaScript. And that results in this rendering pipeline that goes from, the DOM is not on here, but we have that kind of, and then we change that or move things around with JavaScript. Then we basically calculate the styles, like the CSS that is basically the result of the JavaScript being applied to the DOM or the DOM itself. We then put the boxes together, and then we draw them onto the screen, and then we put things together again. So that's the first thing where I got, wait a minute, why is there two things that sound like putting things together? So let's have a look at that in more detail. First things first, there's a bunch of artifacts on the way there. The first thing that we get, or that we start with, is the DOM. That's all our content in hierarchical order. But that's not graphic, right? That's just a bunch of text, really, that then gets passed into a tree, but that's all off the screen. There's nothing on screen. The DOM itself is not on the screen. And then there's something being created by the first step of our rendering pipeline, which is the CSS object model. And that, again, is basically just a tree. So basically, that is the browser putting more text onto the text that it already has, but it's still not on the screen. And then it creates layers. That's the first thing that potentially goes onto the screen, and we're going to see that in a lot more detail later. And then finally, it puts it into a page. And the page is the thing that you hopefully see unless you're offline. And if you're offline and have Service Worker, then you're good as well. Fair enough. So let's start with the styles. So we have a bit of DOM, we have a div, we have a text, and we have a bit of CSS that acts on this piece of information. Again, that's just text. There's nothing on screen yet. So basically, it's the version of me going, hey, everybody, I've got some stuff that I want to put on people's screens to use and have fun with. and hopefully enjoy experiencing. And then this goes forward, so it looks like this. We have the DOM that kind of is this bunch of text that is more or less hierarchical. And hopefully it is hierarchical. If you screw that up, then bad times ahead. Then you have a bunch of CSS that is basically organized in the same way, and then you can merge the two, and then you have the things ready for figuring out what it's going to look like. But the actual figuring out what it's going to look like is called layouting. That's the equivalent of me going, okay, so I have this thing here, and I'm going to put it here. And I have this image over here that I'm going to pile on top of it, I guess. And then I have this over here that okay, no, never mind. I'm going to lift this up a little bit. Hopefully nothing falls down. And then, okay, right, sweet. So that is something. And as you can literally see, this is something, but probably not very visually pleasing. So it looks like this. This is what the browser does. As it parses the DOM and the CSS, it starts creating a bunch of boxes where things will go, right? That's still not really what we see on the screen. We're not seeing a bunch of colorful boxes. Maybe we do for some applications like Tetris. But most of the applications might be slightly different. I don't know about your typical, I don't know, airline check-in. It doesn't really look like that, does it? I wish for some it would, because it would actually be an improvement, but let's talk about that offline by a beer. And there's a thing that you can do wrong at this stage, which is called layout thrashing. So as you can see, the browser was pretty busy putting these boxes together and moving them around, right? And maybe something else later on comes and actually goes somewhere else where you would not expect it, and then things have to change and switch and shift a bit. So that means that it's a lot of work. And the worst thing you can do is you can make it harder on the browser by doing this, called layout thrashing. Who here has heard of layout thrashing before? That's not enough. So basically, here's the thing. If you do this, bad. Layout thrashing means you're basically saying, hey, by the way, browser, that thing over there, make that 200 pixels wider, and then go, oh, actually, how large is it now? Ah, all right, okay, 300 pixels, cool. Then I'll make it 400 pixels wide. How large is it now? 400, okay, sweet, sweet. And basically what you do is you write to the DOM and you read from the DOM right after each other. Because the browser tries to be clever and goes like, you know, this is one change in JavaScript, but maybe there come more changes. So it's trying to batch them together and only do all this work in one step. But if you constantly ask, after you changed it, you say like, make this 300 pixels, how large is it? And they're like, I don't know right now. Come on, seriously, I don't know if there's a border. God damn it. Okay, 305 pixels. All right, now make it 400 pixels. Okay, I'm going to do that. Maybe someone else, anyone else? Hey, how large is it? Oh, god damn it. Okay, fair enough, 405 pixels. God damn, get your stuff straight, man. So basically, you screw over the browser by disallowing the browser to batch these things together and save on calculations. Don't do that, because if you would do that to me and I'm your browser, oh boy, I'm going to give you a bad time. Now comes painting, and that's the equivalent of me. Actually, this is better drawn than I could ever draw this, but okay, whatever. By the way, illustrations are done by my colleague, David, and he's amazing, and you find his Twitter link later in the presentations, and you should totally hire him for doing this kind of stuff. He's not available for hire, though. Play it on you. Anyway, so painting is about actually filling in content, right? So here I have a page with 3 things, my infamous Twitter picture, a headline, and some blob text. So the headline goes first, and the picture goes in on the left, and then the text goes on the right. So, right, yeah. And then it looks like the thing on the right-hand side, and it's all already, no, it's not. What the hell is going on there? Anyway, so this slide is slightly botched. But it puts things together. So it uses the boxes and the actual content to put together the website. Problem is, as we have seen, this involves painting actual pixels. So this means someone has to, the browser really, has to go there, okay, dotting in this one, and this one is green, and this one is blue, and that takes a little while. So we want to minimize that. But Martin, you might say, as the running gag on Vasily's presentation goes from last year, but Martin, you may say, if I want to change things, I have to paint. I mean, I have to get the pixels on the thing again, right? There's no way of doing this without actually, painting. I mean, I have to paint the pixels, and then I can't really move them around. Surprise, that's not true. Because there's compositing, because now I know what I got wrong. So, sorry, my bad. Here, it just paints these 3 parts, and then comes compositing. Sorry for that. mind glitch, where it takes these three parts. So this is one part, this is one part, this is one part, again here. This is one part, this is one part, and this is one part. And it puts them together into the actual page. That's compositing. But how the heck does that not involve painting again? Well, if you think about it, it's like this, where basically you have painted the different blocks, right? We saw that earlier on, that I was there doing my job of painting a horse onto a block of stone, and now we put the stones together into the actual page. So there's no painting involved anymore. It's just literally just moving things around on the screen. So like, okay, this goes here, that painting goes there. It's like creating an art gallery, right, or an art exhibition where you just put the paintings on. You don't really use your, well, some people might, and then the artist may get really angry if you just go like, I don't think this line should be here, so I'm just going to rub it off. There's this infamous modern art piece where someone put a piece of butter onto a large canvas on the corner, and the cleaning staff goes, ooh, who does this? God damn it, millions in damage. Luckily here there's no millions in damage involved. This is actually kind of the thing that we should like. You as a developer should, or designer should fall in love with this kind of stuff, with this particular step in the pipeline, because this means that you can move things around without actually having the overhead of having to repaint all your pixels and basically still get like a dynamic website that looks great and is fast, right? So yeah, this is very simplified though. Actually, it's a little more complicated, but let's stick with it for just a second, all right? So because I can hear someone already going like on Twitter, like, that guy has no idea what compositing is actually doing. It's not true. Just bear with me for a second. So there's a bunch of ways going through that. The internet is full of people like that. I don't know where they hide in real life, really. Don't be that person. Thank you very much. Right, so there's a bunch of ways going through that pipe, right? So we have this bunch of steps. And the easiest thing to do, really, is to just, I don't know, let's say I make a font large. If you hover over something, I make the font larger and change the color, and I make it rotate or wiggle or whatever you want to do these days, because it's super cool and everyone does it now, and it's part of the 2 designs that everyone has to do. Then you go through all of the steps, meaning you do all the work, right? The JavaScript executes, maybe adds a class to something, like a hover. No, hover is a bad example. Maybe you add a class, let's just deal with it for the second. Then it recalculates the styles, and it has to maybe, because it's resized, the font size is larger now, it has to relay out things, but it needs to move the boxes. It needs to repaint the pixels because the color is now red. So before it was black, we had black pixels, now we have red pixels, so we actually have to do some work. And then we composite by putting back the boxes together and be happy. A lot of work, isn't it? Even describing it is a lot of words already. So there, you can basically, if you're careful enough, then you can spare the layout bit, which is the most expensive bit, really, in terms of what the CPU has to do. By saying, you know what, I don't change the dimensions so it doesn't move around and it doesn't actually disturb the order of things. So basically, if you imagine what would be a layout change. So if I would ask you to get up and come to the stage, you would do a layout change because everyone would have to get up and then, oh yeah, I'm sorry, excuse me, no, I'm sorry, and you do this entire acrobatic dance. Whereas if I just say like, you stand up, that's not a layout change because everyone else can just sit, right? So even changing dimensions, for instance, for things that are positioned absolutely, is not necessarily a layout change. But basically, as long as you do not touch the order of things in your document or on your page, you're fine. But still, you have to maybe paint things. If I say, hey, you over there, change t-shirts, then you have to repaint yourself in a different t-shirt color. That might be a little, involved, especially me being mic'd up. I would be like, Russell, and it would be really nasty for you guys. Because you don't really want to see me change on stage, really. Anyway, so that involves painting. It's still a bit of work, but it's less than actually doing the full part of work. Obviously, if you take something away, it's better, because we want to avoid things. And then the best thing would be, we have a JavaScript that kicks in, an event handler or something, that changes the style, that does not have to do any layout changes or paints, because it's, for instance, a CSS animation that just, changes opacity. But wait, you're going to say, how does that work? Because if you change opacity, then pixels on screen change. Not quite. Yes, they do, but the way that the compositing works is basically, you put each layer, and elements can or cannot be on different layers. You take each layer and you combine them together, and that can work on the graphics card. And the graphics card can do a lot of amazing things that we're going to go into in more detail starting from now on. But keep this in mind. If we are happy little people, then we actually are going to be in this part where we basically only do compositing. Right. Layers. I talked about layers. What the hell are layers? Well, the thing is, the browser wants to really reduce their work. And when I say, well, when we had this analogy with the blocks where things are getting painted in and then the blocks are being put together, each of these blocks is called a layer in actual technical terms. So each block has a bit of a downside, which is obviously it has to be created and put into memory, so it actually increases memory consumption a tiny little bit. But as long as you don't overdo it, you're safe. And actually what it gives you, the advantage of having different layers, is that if some repaint happens without actually changing the layout, if some repaint happens, you only have to repaint this little image. Right? So for instance, if I have an avatar image and some really long text, and I change only the image, and it's on a layer, then I only have to change the image layer, and compositing is going to put it back in. Right? So I only take one block out and put one back in. Versus if it's one large layer, the browser does some optimization, but technically it doesn't know that only this small part has changed, so it has to do the entire thing again, which is slower, obviously, because it's paints. There's a bunch of elements or two elements really, that by definition create their own layers because they change a lot and have to be repainted a lot, which is video and canvas. Video element kind of makes sense because we want to hopefully have 60 frames per second or 30 frames per second, whatever your video file supports, changing all the time. So 30 times per second, the image is going to be repainted, and you don't want to repaint the entire page, so it's going to put into its own layer so that we only have to repaint this one thing. The canvas is there for this particular thing that you want to have pixel control. So any of the pixels can be repainted at any time, programmatically using JavaScript. So we also want to have it on a separate layer. And here is why 3D transforms are so, well, let's put it that way, popular in CSS animations, because they live also on their own layers when you use them, 3D transformations. So for instance, translating X or Y does not necessarily work, but translate 3D into some direction actually does not repaint the entire thing, but it actually just uses the layer and just positions it, which is nice. Composite-only animation is animation that basically does not change layout and does not need repaint. So if you change color, for instance, that would have a repaint effect because you can't really trick around changing the color. But those animations then go onto their own layer. Also, and that's the fun thing, animations, because browsers are clever, most often go onto the layer. But still, there might be animations that are then on their own layer and do not repaint, but still are not very like what you would expect them to be in terms of how they work. So it's not only 3D transformations, it's actually a lot of animations that might be surprising to be on their own layer, but it's really convenient that they are. And then there's this new property. Who here has heard of will change property in CSS? More, but still not enough. So, so you can force layer creation. Does anyone know how to force layer creation without it? Yes, say something? Correct, yeah. So basically you do a transform in 3D that does nothing. And then it goes, oh, there's a transform 3D, so I'm going to make a layer. Because it doesn't matter if it does nothing or if it does something. But that does not have to be there anymore because you have a will change property that is a more semantic way because it's more obvious to read, like why do we translate and then do not really translate while we are using it. So I'm just going to delete that rule and then your performance sucks. So that's why there's will change, because then you see will change and then you're like, okay, so this thing's probably going to do something that needs only compositing if put on a separate layer. As I said, layers are great for performance because they allow you to basically isolate the changes and then just have to move them about. But they need not only more memory, they also need more management because you have to have a list of layers that compositing gets. And this list has to be managed, so there's a little overhead. Which means you should not just make everything its own layer. That's a bad idea. All right? Measure and then inspect if you see an improvement, if you use a layer for something, and if you do, great. But don't just use a layer because Martin said it's a great idea. Don't misquote me, please. So compositing, as I said, I simplified that one, so let's have a look again. And now it's still a lie, but it's less of a lie than it was before. It's a lie because I only have 45 minutes in total and not 45 days, so let's just cut it down a little bit. So here's what composition more or less really looks like. So we have a bunch of layers created by the way that the style sheets set. So we have a bunch of transformations, these famous, wonderful 3D transforms. And then we have a bunch of filters that you hopefully have seen in Yuna's talk. If you haven't watched the video, it was great. It is definitely worth a while. Right, and then we take these three inputs, or well, layers might be more than just one, obviously, and put them together using the graphics card. And the graphics card can do a lot of weird things without having to repaint pixels. And we're going to go into the details of that in the next couple of slides. The outcome of compositing is a rendered frame, so basically the huge image that is your browser content, and everything looks great, and everything works, hopefully, as expected, and is fast as something, as a unicorn. Time for a quiz. I hope you're not all checking emails. If you do, continue. There's no prizes here, so I don't really have a lever, but I may look at you angrily and go like, anyway, sweet. So here we have some piece of CSS and a piece of JavaScript that after 2 seconds changes the style. And the question I'm going to ask you is, will it paint? Okay, hands up if you think this paints. Hands up if you think this paints. All right, sure, there you go. Have a close look. Yeah. All right, so does it paint? Let's have a look. If you see green flashing, it paints. Dun, dun, dun. It paints, right? There's a fat green rectangle. Why the hell does it paint? Look at it closely again. Translate X. What the hell have I been talking to you about 20 minutes ago, 10 minutes ago, whatever? Translate X is not a 3D transform. It's a 2D transform. It does not create a separate layer. We are screwed because we get the green triangle of sadness. Sorry, rectangle, not triangle. So here we go again. Similar code, slightly changed. It still changes the styles after 2 seconds. Will it paint? Show it again. 21, 22, 23. Will it paint? Yes, it will paint. Who here thinks it's going to paint? We should give out more coffee, I think. I'm sorry, great answer, yet this creates a layer. You can see that by the little orange outline. This has created a separate layer. And because we now have basically 2 images, so each layer basically you could imagine as being an image, right? And that's going to go into the graphics card. And then the graphics card just puts image after image, and then goes, ooh. It's a little like this magic trick that I learned as a kid, where you go da 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 da. I can't. Jesus Christ, how did I do that? But now I know, like, ooh, my thumb, and then you go right. So it's kind of like that. You have these 2 different distinct images. By the way, don't worry, my thumb wasn't hurt. The trick goes like this. You put that thumb in here, down here, right? And you put the other thumb up, and you go like, ooh, and then you just, it's misdirection, really. No thumbs were being harmed. Right, with that out of the way, this creates these 2 images and then just moves one image around. While as the other one has one large image, but it has to somehow move this part of the image over. How, right? The graphics card is not going to open Photoshop and do a crop select and then move and then just, save as PNG and then go, no, not there, over there, yes. And then browser's going to display that. No. So this is basically the basics of composition. You have 2 different images called layers, and they're going to be moved around, and that's fine. Okay, now let's put this to a last test. Wonderful. Another transform ID. Another diff. There's a CSS animation involved. Ooh. And the CSS animation has a translate X, like in the first one, but it's a CSS animation. Will it paint? Hands up who thinks it's going to paint? I love how people go like, I bet there's someone in the audience that I can't see due to the spotlights going like, God damn it, wait, just 1 second, I'm gonna, Jay's bin is not reloading. Was that a return key? Come on, just reload. All right, here's the thing. It's not painting. Ta-da! Because basically using this animation and to translate 2D, the browser's clever enough to go like, it's kind of like, and it's an animation. You know what, I'm going to put it onto a different layer and I'll be good. Surprise! So everyone has woken up, I guess? Right? Yeah? Sweet. Now you know why you should listen to me. God damn it. Good, it's recorded, so you can go back and go like, what is that? Right. So then there's filters that you have probably seen, or maybe not seen, but you should totally check out the video from Una. There's a bunch of them. I'm not going to go over them in too much detail. But the cool thing is, they also are composite changes, so it does not repaint. And that's what makes them fast. And the thing is, there's a bunch of articles that are super outdated or slightly weirdly worded. So for me, as a non-native English speaker, born in Germany, I don't speak German. I don't speak Swiss German, though. Not really good, at least. Right. So yeah, there's one article in particular that said, use accelerated filters. And I'm like, what are accelerated filters? And when you Google it, you find a lot of nonsense. Not nonsense, but things that have nothing to do with CSS, which is hilarious. And there's some not safe for work stuff in there, just saying, which is super weird. I'm like, oh, that exists. Interesting. I'm not going to brush my eyes with a toothbrush. Right. What has been seen cannot be unseen. Why did I do this talk? I must be masochistic or something. Right. So here we have a filter that basically, there's a gray diff, and we change the brightness from 1.0 to 0.5 after 5 seconds. And because the browser is nice, the question, will it paint, resolves to yes. Wait, what? So here's the thing. Filters do not necessarily create layers. They are all accelerated. All filters are accelerated if on a separate layer. Right? Same problem as beforehand. I have a huge image, and then I have to do this small thing, has to be brighter or darker than beforehand. Right? The browser goes, whatever. I move along and paint. Right? And then you do another change. Here I use the translate Z hack just to illustrate that. And you see here that there's a border around this one now, which is the layer border. And now it does not repaint. There's no green rectangle of sadness anymore. So always make sure, if you use filters, to use them on layers. That does not go for background blend. This is a mix blend mode, so for different elements to blend them together. Anyway, blending we come to later. Again, just to driving this point home, here there's no border around the first one on the top. That means there's no layer. The second one has a demarked border around it, not because it has CSS border something. No, that's just because demonstrating it is a different layer, all right? And if it's a different layer, you get the composition only change in filters, which is nice. If you do not have a separate layer, you're going to have a bad time. That was CSS filters. There is the overview of filters that exist. Then we have blending. That's the mixed blend mode. So how the hell does blending work? Well, blending technically is just you have one layer and you have multiple elements within the same layer. And these elements have to somehow be, painted initially, right? And they may overlap, and they may be opaque, or may not be opaque, might be transparent or something. And then you have to figure out how the color in the middle, where they intersect, looks like, right? So here we have two diffs. We have a blue one and an orange one, and they overlap. Normally, how it would look like is you would probably just see the orange one or the blue one, depending on the order that you put them in and the Z index you're using. But here I'm using what's called a difference mode. And what difference mode does is it goes from each of these colors, basically treating them as values from 1.0 to 0.0 for red, green, and blue, and then basically just, subtracts them from each other and makes sure that the range is between 0 and 1. So here we have 1 for the orange triangle in the red channel, 0 for the blue, triangle. I keep saying triangle because I did a lot of WebGL things. Rectangle, so you have 1.0 for the red in the orange rectangle, you have 0 for the blue one, and that gives 1 minus 0 is 1. Great. 0.5 minus 0.5 is 0. And 0 minus 1 is minus 1, but that's outside of 0 and 1, so we're going to put it to 1. Great. So that's one of the many blend modes. There's a bunch of blend modes available. I'm not going to go into too much detail about them. There's a brilliant link as well. And you can see that the original one, the very first one on the top, just puts one thing over the other, and the other one does different equations. So there's different math going on, but the principle is the exact same. And the cool thing is, by the way, that's also, because it happens inside a layer, it repaints for the first time, but then basically everything else that happens when you change them dynamically, that's going to be just composite, because the compositor is magical. It can work within a single layer, but not really when it doesn't know what to do, really. It only works for blending modes, only blending modes. There's reasons for it that are really hard to explain, so I'd rather not explain them. It has something to, if you really want to know, you basically have to get into WebGL, which is great. You should do that. Right, beyond CSS, speaking of WebGL, there's 2 different APIs that we can use to get straight to the pixels and just ignore everything else, go straight to compositing, and even have control over compositing, how exactly that works. The first one is Canvas 2D. Who here has worked with Canvas 2D before? Hands up. Good, nice. For those who haven't, it gives you an API that allows you to draw pixels and lines and rectangles and triangles, all kinds of things, brilliant things, images onto the canvas, and then you can basically use pixel access. So you can say, I want the 25th pixel on that line to be green, which you can't really do that easily with CSS, can you? It also has a competitor, if you want to call it like that, or an evolution, which is the WebGL context. The WebGL context is most famous for being awesome for 3D graphics, right? Who here has used WebGL before? Nice. Well, actually not, because it's not very many people. You should use WebGL. It makes sense. You're going to see a code example in a bit. So what's different here is, so 2D gives you access to the pixels, but not through the entire graphics pipeline in hardware. WebGL gives you a little more access to the hardware, so you're really close to the actual graphics hardware, and you can influence how compositing works, for instance. You can't influence the compositor in Canvas, except for using some methods that it exposes, or using filters or blending modes, but you can't really fine-tune it. With WebGL, you get to write programs that do the compositing for you. So basically, you write code that runs on the graphics card. Not in JavaScript, though. But hey, it's pretty cool then, anyways. So this bypasses the entire pipeline, whereas Canvas 2D only bypasses basically the layout step, really. Right. So here's the showdown. Because why would you pick WebGL, or why would you pick 2D? And would you pick WebGL for 2D? If you have used a bunch of these different JavaScript or HTML5, they call themselves game engines, then you're going to probably see that they are defaulting to WebGL if you don't ask them specifically to use Canvas 2D. Why is that? I wondered. Here's a bit of code for the canvas. So here, this code is basically going up to an arbitrary number of things that it has to draw. And it's going to draw them onto random positions. HD width just means like where on the screen I can go with this. So basically, it's a random position somewhere on the screen. And it's the random size, maximum 512 pixels. And then we're going to draw an image that we have loaded from somewhere onto that position in that given size. And we draw a lot of them. Let's see how we do. So here you see the height of how tall the bar is means how many frames per second we get. And the columns mean the different number of objects. With 1 object, we get 60 frames. We're good. With 100 objects, we get not that many frames, and then it goes down the hill. So basically, the problem is you want to be on the green, bright green line, because that's 60 frames per second. That's awesome. 30 frames per second, that's like 2005 stuff, man. And then everything below 15 frames is not going to look good. It's basically a slideshow rather than an animation. So how about WebGL? So I've shown you this code for Canvas 2D. So how much more can it be for WebGL, really, right? That. And that's not complete. That's just the very basics to get everything up and running and do the code. Don't try to read this. You know it's online. Please just don't, because I can see the tweets going like, "Did you see that slide? Oh my God!" No, don't read this right now. Have a look at it later. Slides are being online, but it performs slightly better. Just a tiny little bit, you know. It's like the tiny little bit in showers, right? It's like this difference between frickin' freezing and scorching hot is between this and this, right? Anyway, so yeah, it's more or less obvious that this is much faster. But why is it so much faster? I mean, in the end, it's just 2D things. I mean, we haven't really done any like 3D cube kind of thing or any spaceship stuff or whatever. No, we just had an image that was drawn and resized. It's because the painting step on canvas has to do everything, basically. And in WebGL, you can bypass that by using clever compositing that you have to write yourself. Well, you don't have to. There's libraries like 3JS that do that for you, but still, it's a nice difference, and you see quite a big outcome. However, these results might be slightly skewed because Chrome is experimenting with 2D acceleration, where they try to be cleverer with the compositing. So you may get your mileage might vary, but generally, it is not necessarily a bad idea to think if WebGL makes sense for your 2D canvas use case as well. And this is why WebGL is fast. That's it in a nutshell, right? So Canvas more or less has to paint the pixels one by one because it has to figure it out the compositing in software. And the graphics card is really, really highly optimized to draw a lot of pixels in one go. So even if you have just 2D graphics, it does a lot of pixels in one go, like this beautiful painting of Mona Lisa, which is artfully applied to a canvas. Thanks, NVIDIA, for this one. NVIDIA and Mythbusters, I believe. So let's quickly recap. Try to minimize layout work that you do because it's super expensive. Try to minimize paints because they are also pretty expensive. Use composition only wherever it makes sense, but it might often require layers. And layers come with a memory overhead and management overhead, so you want to not overdo that. You can force layer creation, but again, be careful when you do that. Right. Yeah, and then even you might be doing 2D graphics. Do consider WebGL. It's a little more code. It's more code, slightly more, you know. And yeah, there's a bunch of reading materials. The last one is not a link. I was made aware when I showed the slides to a colleague. It's like the last link is missing. It's like, yes, I know it's missing because I want to use this as a pressure point for me, and now we have it on chem. I am writing a freaking article that explains all the things WebGL, and I really have to get that done. So ping me on Twitter when it's not on that slide in like 2 weeks. I'm going to hate me for saying that on stage, but hey, gotta live dangerously. And with that, ladies and gentlemen, we are done. Thank you so much. Slides are already online. Illustrations can be found on Twitter, not on Twitter, but the illustrator can be found. David is an amazing guy. Give him a heads up. He literally, I called him yesterday and like, David, I have this crazy idea. And he's like, yeah, because beforehand he said like, I want to do an illustration. I'm like, yeah, I have this crazy idea. He's like, oh yeah, that sounds awesome. When do you need it? Tomorrow, latest 13:00. And he's like, all right. So big hand of applause for David, really. Thank you very much.
Thank you. That was so much to take in.
I'm so sorry, yes, but the good thing is it's recorded so you can then...
Exactly. So much to take in a good way.
Ah.
We like a content-rich presentation, for sure. Who has questions?
It's one way of putting it, isn't it?
Oh, that hand at the back. I've got a mic to begin with.
Okay, thanks for a very nice talk. Simple question, browser compatibility. Where does this work? In particular, does it work in Internet Destroyer and from which version onwards?
Internet Destroyer, karma points for that one. However, to be fair, the Edge team does a great job in improving that, so don't, shit on other people's work. So yeah, so compositing and filters, so compositing, every browser does compositing, full stop. If it does it GPU accelerated, it's a different story, and that's depending a little on your hardware and browser. It's a little hard to answer that one. Most of the properties are supported across all browsers, except for will change. The translations might not work in Internet Explorer 6 if you have to support that. Don't laugh, Asia. Then, sorry. WebGL works starting from Internet Explorer 11 upwards. If that answers the question. That's as good as I can get right now without going into a monologue for another 45 minutes.
Do you
Thanks.
use Can I Use or something like that?
Oh yeah, you can use Can I Use. It's all on Can I Use, and highly recommend because it's keeping update. But yeah, WebGL is a little trickier. Can I Use does not work that well. Yeah.
Any other questions?
Yes, there's one.
Aha.
Yeah, it was
Hiding behind the
lec-
podium.
Yeah, exactly. It was behind the podium. Sorry.
Hi, thanks for the presentation. What about mobile phones? Because I see lots of graphic card acceleration going on.
Right. Mobile phones, surprisingly, have mostly capable GPUs, and browsers do leverage them. So Internet Explorer. Nice. Mobile Internet Explorer 6, the future. Mobile phones, Android 4 and iOS starting from 8 are capable of pretty much everything that was in the presentation. Not sure about will change, though. But everything else, acceleration definitely exists on mobile as well.
Thanks for the presentation, Martin. So you do a lot of stuff with WebGL shaders, I guess. So I was interested. So you also paint 2D stuff with WebGL shaders?
Oh my God, no.
No.
Because we don't really do that much 2D stuff.
Okay, but you could, right?
You could totally do that.
What do you do when the maintenance of your software, when you write shader code, right? It's kind of writing C code back in the days, right? So what do you do for maintaining this? Can you suggest a structural approach or a loading approach, or?
I'll do a quick charade because it really lends itself to the situation. No, just kidding. So there is, speaking of loaders, there's GLSLify, so that allows you to basically modularize your shaders and use them with Browserify. I'm sure there's something for Webpack and all the amazing other build tools out there that I have not used yet. So yeah, in terms of maintenance, making modules and then using NPM and Browserify is the thing that a lot of people do for that. Yeah. Welcome.
Any more? Do you have to get a stupid question from Laura? Okay, so aside from the wiggly buttons and badges and things, what do you think is the most common crime that people are committing when it comes to rendering?
The most common crime is probably using JavaScript to animate rather than actually using web animations or CSS transforms, because that's just very bad. As I showed, if you move for instance, if you resize the button on hover for some reason and you use JavaScript for that to animate that nicely, it's just going to be horrible. So don't.
Do you think that people are mostly doing it because they're more familiar with those technologies than they are with the newer stuff?
jQuery. No, there's a thing, you know, a lot of people started with animations using some jQuery plugins, and a lot of people wrote them in the early days when there weren't any browser internal things that actually allowed you to write performant animations, and then they either stuck with the old versions, or, I don't know, stuck with plugins that are no longer maintained, and then just accidentally use things that are not fast, and then go like, oh, the web is horrible. Or even worse, the DOM is horrible, I'm going to do it all on canvas now. Losing all accessibility. If you do that, a kitten dies. So, yeah.
So do you think that the approach now would be for developers to, when they're working with people that aren't necessarily technical or working with clients, to explain to them and encourage them to use these newer technologies like this?
Definitely. So the best thing you can do is, if you profile using the developer tools, then you get a timeline of what happens and where time is spent. And if you see because a lot of clients then go like, our website is slow, why? And then instead of fixing the backend or fixing, I don't know, style selectors, because a lot of style selectors are actually not slow by definition, like using a lot of style selectors is not necessarily slow. you could profile, and when you profile, you can show the timeline and say, like, look, this amount of time here is spent just painting pixels, and if we switch this tiny line of code to this other tiny line of code from JavaScript into CSS, then this entire thing goes away. And that's very visual and very easy to understand for clients, I believe.
Cool. So if, like me, you're just starting out learning about these kinds of things, what should us noobs, what's the one thing that we should take away from your talk?
Learn the basics of what happens in the rendering pipeline. Not in the depth of the talk necessarily, but the one thing you should definitely have a look at is CSStriggers.com. CSStriggers.com is a website from Paul Lewis, I believe, that lists all the CSS properties and what they do. Like, do they style? Do they lay? Well, they do style. Do they layout? Do they paint? Do they composite? So you learn a bit about on what does what. There's also a quiz based on it. So take that
so
quiz.
you can
you can quiz yourself. Like, does it trigger layouts? No. Oh, it was wrong. Like, yeah.
So much like your talk, we can learn how stupid we are.
Yeah, no, it has nothing to do with stability. I mean, I was surprised by 90% of the things that you just saw. Until
it's not necessarily obvious.
It's not obvious at all, unless you really go into the details and depth. That's why I'm here, why I wanted to share all the WTF moments that I had. Because I felt dumb, and now I kind of I still feel dumb, really, but share the dumbness.
What's the most exciting thing you've been doing with your work, given the complexity of the things that you're rendering?
Okay, so the most exciting thing definitely is virtual reality on the web. So you can use our tool in Google Cardboards or Oculus Rift or HTC Vive, and you can actually literally walk through spaces. And the thing is, the weird thing that I learned is that you have someone come into your office and go like, the visual quality of this is crap. And then they put on Oculus, it's the same visuals. It's literally the same visuals. And you go, wow. And they're like, all right.
I think if any of you watch Grace and Frankie on Netflix, they've got a bit on that, on exploring real estate using virtual reality. It's very good. Well, was that a hand? No, I'm imagining. Oh, brilliant! Down here. Oh, you get it.
Hi, I'm Adrian. Thank you very much. I would like to build a bridge back to Yuna's talk about the SVGs and the filterings and all that kind of stuff. So my question is, does it matter how I structure my SVGs, like using the Gs and maybe pulling in references from URLs, stuff like that? So does that affect performance in any way, or can I just do whatever I want?
Wow, that is an amazing question because I don't know the answer to that at all.
That's also an answer, thank you.
Sorry.
Does anyone else know the answer to that?
SVG is tricky. I don't want to get into that hairy bit. SVG experts to the front. All right.
Are there any more questions?